As we scan through this question, it looks like we've got an exponential model here. So let's read what the variables are. Theta is the temperature of a cup of tea, and T is measured in minutes after that cup was just left on a table. Okay. You may want to just think about that function as an exponential decay graph. If t is 0, we're at 25 plus a, and as t goes to infinity, the exponential term becomes 0, so the long term is 25. There's a horizontal asymptote there, and a sort of decay shape over time. Okay. The temperature of the tea was 25 when it was placed on the table, so that's an initial value. So it looks like we've got some data. T is 0, temperature is 75, and the question is find a complete equation for the model. So I think by complete they mean find that missing value for a, the unknown value. So let's substitute our data in. 75 equals 25 plus a e to the 0. E to the 0 is 1. So therefore, a equals 50. So let's specify that model then, nice and clearly. Theta, therefore, is 25 plus 50 e to the minus 0.03 t. So that temperature, our initial temperature on the graph, is 75 before the exponential decay. Okay. Part B, use the model to find the time taken for the tea to cool from 75, which is the initial temperature at time 0, so we don't need to do anything clever with that, to 60 degrees. Okay, so we need to find the time when the temperature is 60. So t equals question mark, theta equals 60. Let's just substitute again. So 60 equals, we have our model here, 25 plus 50 e to the minus 0.03 t. 60 minus 25 is 35, and if we divide 35 by 50 we get 7/10. So e to the minus 0.03 t equals 7/10. Then we need to learn both sides, because learn is the inverse function of e. So on the left we get negative 0.03 t equals learn 7 over 10, and if you put that into your calculator you get t equals 11.889. And if we read the question carefully, they want that in minutes to 1 decimal place. Well, t is measured in minutes, so that's good news, but 1 decimal place means we need to round that to 11.9 minutes. Okay, that's part B done. What's next? We've got a little bit more story now. So 2 hours after the cup was placed on the table, the temperature was measured as 20.3. Evaluate the model. Explain your reasoning. Okay, and actually if we look back at our graph, something doesn't seem right here because the graph has a horizontal asymptote at 25. The model never predicts a temperature below 25, whereas the reality has a temperature of 20.3. So I think we could explain this from those properties of the graph, or specifically we could look at that 2 hours value and do another calculation. Okay, so let's answer this in 2 ways. Just split the page up. So on the left we've got, we're going to look at the model versus reality. So from the graph perspective, we can see that theta tends to 25 in the long term, but the reality is that theta was 20.3. That doesn't look good, does it? Or let's do it from the 2 hour data that we're given. So we're told that when the time is 2 hours, that's 120 minutes. The model, if you substitute 120 minutes into the model, gives you a predicted temperature of 26.4 degrees. Whereas, again, the reality, someone measured it, is that it's 20.3 degrees. So no matter which one of these you look at, either the long-term graph or the 2 hour data, both ways we see that this model does not seem to be appropriate, so it's not valid. In the long term, 2 hours is a long time after the start of the experiment. At the beginning, it might be great, but model is not valid for long-term temperatures. Okay.